I know you found it because I know there's a mistake on that one. So we have 140, which will lead us to half it. So that would be 7 degrees. That was not the mistake. So my x should be 70 degrees. My y would be double 155, which is also not the mistake. The mistake happened at the next part. So if I have 70 and I got 55, what's the missing angle of the triangle? 55 degrees. What happens when I double 55? 110. Z should have been 110. I think in the answer key it said like 130 or something. That should have been a glaring mistake. Did anyone else? I'm going to give someone else a chance to see if they found the other mistake. If they didn't, otherwise we'll go over. Did anyone find another mistake? Okay, which other mistake do you think there is? Number 11. I don't think there's a mistake on number 11. We will go through it. Number 11 is a really good one to go through. So number 11, we should, let me just double check to make sure I have it correct. It's
just for Z, I got 160 on your answer key. In the writing, it said 160, but on your actual answer, I don't think it said 160.
Oh, okay. Well, it said 160 though, right?
No, like for the Z on the line, it didn't say 160. It said a whole other number.
For Z.
It said 100.
Well, it's probably just a 0 and 36.
Oh, it's just my 6 is terrible. But you still found the mistake. But you got, so on the thing, it should be 60, right? 160, okay. Well, Z should not be 160. Z should not be 160. Z is, can we all pay attention to this one? This is a really good one. This is a great one to put on tests and stuff. Z is not 160 because what is 160 is that right there. That entire thing would be 160. This entire thing would be 160 degrees because that would be our 80 doubled would give me all of this. Just like if I didn't say that Z is not that, Z is this one here. If I double 170, I'll use this in a different color. Double 170 and I have this orange section is 140. So Z can't be 160 because Z is just from here to here. It's got to be less than 160. So what we're going to do is we're actually going to use the fact.
Well, if it gave 140 and 120, you just add those, right?
What was that?
If it gave us 140 and 120, can't you just add those and then subtract?
Mm-hmm. So 140 plus 120 would equal 160. 360 minus 160, I'm sorry. Yeah, 360 minus 260 is going to equal what? 100 degrees. Z is going to be 100 degrees. And I do have 100 degrees, I think, on the answer key. So it is 100 degrees. Do you see why it's 100 degrees, not 160? Okay, so that'll get me that 100 degrees there. Maybe going around the other way, do you see this 160 and this 120? 160 plus 120 is 280. 360 minus 280 will get me this little section right here, which would be 80 degrees. So this little section here would be 80 degrees, which is actually going to leave us with 60 degrees here. And after that, you should be able to get all the rest of them. Okay, what questions do we have from the homework? Let's go, Grant. Not Grant, because you leave in 4 minutes, right? Sorry.
Can you go over 16?
Yeah.
Just the sum.
Yep. Guys, do you mind not talking for a second? Okay, so number 16 says VQ. I'll try to hurry up because I know you got to leave. VQ equals y plus 7, right? I'm actually going to, just for setup-wise, I'm going to go to the only other important thing right now, and that is the 65 here. Surprisingly, I don't need anything else to start solving. If this is 65 degrees, and this right here is 90 degrees because we do have that central angle, 65 plus 90 is 155, which is going to leave 25 degrees right here. I'm going to go ahead and I'm going to erase this real quick. And I'm going to put that as the central angle because it kind of keeps it a little neater. Do you get how I got that 25 degrees out? So now we're going to have y plus 7 equals 25 degrees. We're going to use that to find y. And then let's bring in the rest of it. So it said QR is x plus 11. RS equals 3y. I will now know that x plus 11 plus 3y equals that 90 degrees. And I'm going to use this to find out y is 18, and I can plug that in there and figure out the rest. Okay. Is that, you just wanted the setup?
Yeah, thank you.
All right, good. Is anyone else going to baseball that has a question? Are you going to baseball? Is anyone else going to baseball? Joseph's face. No. You like answered for him. He's like, no. All right, Grant. Grant was the next one in line. 15. Where's 15? 15's right here. Okay. So, real quick. How many degrees are there if I spin around in a circle? 360. So, going all the way around is 360 degrees. Notice I have 3 arcs. This is split into 3 arcs. I know 2 of the 3 arcs. If I know 2 of the 3 arcs, how do I find that missing arc? You subtract it. So I'm going to do 360 minus 87 minus 39, and whatever I get is going to be right here. Grant, I'm going to make up a number because I'd rather you solve this. If this came out to 100 degrees, what would the inscribed angle equal? 50. So if this is not 100, so don't put 100 down. If this was 100, I would say 5x plus 2 equals 50. Okay, but you'll get a different value out there. I'd rather you do it, though. Okay, yeah, Santiago.
Number 16.
Number 16, we just did 16.
Yeah, I have another question.
Okay, yeah.
Can you say x plus 11 equals 45?
No, you cannot. You do not know that. It doesn't say that it's a bisector. It would have to say somewhere in there that those 2 arcs are equal to each other. Okay? So because they didn't say that, we have to assume they're not equal to each other. Okay? And I don't think they turn out to be equal to each other because it'd be 3 times 17. No, they wouldn't be equal to each other to begin with. So don't just start putting things equal to each other. Try to do it without putting them equal first. Okay? All right, more questions? And Ben is transferring feverishly between calculators. All right. What was that? Yeah, I can do number 17. Guys, good luck. All right, Santiago, we're doing number 17, okay? And the only reason I'm bringing this up is, see how it says bisects? That's how I'll know that it's going to cut something in half. Okay, so here we have given CH, where's CH? Bisects DHG. DHG. So that means these 2 angles are the same. If those 2 angles are the same, then the arcs they subtend are also the same. Elmer, you're the one that asked this one, right? Okay, so then they say, right? You asked this one? Okay. Does that make sense, though? If the angle bisects, then the arc is also bisected because of the central angles. All right, then it says that GF, let's find GF is 2x. So right there is 2x plus 6. And it says DC equals... Are you guys good?
Yeah, sure. I was trying to.
Okay. So this is going to be 7x minus 1. Okay, we are supposed to set up some kind of equation for this. Did I get this right? GF is 2x plus... Okay, we're good. Elmer, here's going to be the key to this. I'm going to have you help me for just 1 second here. Do you remember what this is called? If it's a straight line going through the center. The diameter. Do you know the degree measure of the diameter? 180. So from here to here is 180, right? Now notice that this arc is the same as this arc, so I'll write this is also 7x minus 1 because they're equal. And you told me if I added everything up, it equals 180, right? So I'm going to do 7x minus 1 plus 7x minus 1 plus 2x plus 6 and set it equal to 180 degrees. Is that good enough? Okay. So basically this was a red herring. This EH was just like put there to throw you off. Because I want you to be able to pick out diameters in 180 on your own. Not that I have to draw it exactly, that you can just look at a drawing and see diameters are 180. Okay, what else we got? Yeah, absolutely. Bueno? We're good? All right, buckle in, guys. Buckle in. Whatever you need to do. I know it's Friday, end of the day. We have some tough problems we have to get to. We have some tough problems we can't phase out. They're important problems to get to. So I don't care how boring the problem is. I want you one step ahead of me, thinking ahead of me of what I'm going to do next. And primarily, we get to, we have kind of easy ones, and then we have two hard ones. Let's knock out the easy ones first, the easy properties first. We have, so let's be careful here. Look at the double angles on this first one. What I'm telling you is, if you ever have two chords that are congruent, if you have two, yes?
Are they going to be producing this like at some point?
Maybe. Okay, if you have two chords that are congruent, the arcs they subtend are also congruent. And this works both directions. If two arcs are the same, then the chords they subtend, not they subtend, but the chords they create will be congruent. Let's go ahead and let's just do some practice with those. Let's find 1. We're going to do 1, 3, and 4 together right now based upon that one rule. So like I said, if you see chords are congruent, the arcs are congruent. If you see arcs are congruent, then the chords are congruent. So let's look at number 1. What do we see that's important on number 1? Joseph. All the arcs would be congruent because all of the chords are congruent. So I'm going to go, you know what? Because these chords are congruent, let me change colors to black. All of these arcs are also congruent. How does that help us? Yeah, Ty.
If you subtract 360 by 114 and then divide it by 3.
Okay, I have 316 minus 114. What do I get out? Help me out. 246. 246! Why'd you divide that by 3? Because we have 3 equal sides. Now, as soon as I did 360 minus 114, I came up with what degrees are left over. If I didn't have these marks, I didn't know how it'd be distributed. But since they're all equal, I can say, oh, they're all equal, so I'm going to divide this by 3. So what's the measure? Was it 82? 82 degrees. Now note, that means every one of these is 82 degrees. What do you think would happen if I did 82 plus 82 plus 82 plus 114?
360.
It should equal 360. Now we know B equals 82. Let's skip number 2. Let's go on to number 3. Now just think about it. Don't shout anything out. Don't shout anything out. What equation would you write? For number 3, what equation would you write down? Write down an equation. Write down an equation for number 3. It might be that 7x plus 24 equals 180. It might be that 7x minus 115 is 90 degrees. Don't write any of those. That sounds pretty silly. Who thinks they got it? Who got that? Yeah, Will.
I don't know if I'm right, but like, are these equal to each other? So 7 equal.
What would your equation be?
7x plus 24 equals 115.
Does anyone agree with that?
Yes.
Yeah, you're 100% right. So because the chords are congruent, the arcs are also congruent. And since the arcs are congruent, that means use an equal sign. So we have 7x plus 24 equals 115. Can we take a second and solve that? If you haven't already, take a second and solve it. Oliver, what'd you get? You got x equals 13. Let's give everyone a chance to confirm that it's 13. Can I get a second that say Grant says it's 13, Ty says it's 13? Elmer, Will. Okay, we're all good with x equals 13, so we are done with this one. Number 4. What equation am I writing? Raise your hand. What equation am I writing for number 4? Santiago.
4x plus 1 equals 9x minus 34.
4x plus 1. What allows me to write that they're equal to each other?
Because the arcs are equal, which means the chords are also equal.
Absolutely. Great explanation of that. If the arcs are congruent, then the chords are also congruent. So we have 4x plus 1 equals 9x minus 32. Take a second and go ahead and solve it. What did you come up with? 7. You got 7? I got a confirmation over here. Are we okay with 7? What if I told you 7 was wrong?
You're wrong.
Then I'm wrong, right? Yeah, because 7 is the correct answer. All right, guys. How hard is that property?
That one's easy.
It's easy until it's built into a big picture. So what do we need to do? We need to practice it. We need to practice it to make perfect. The more times you practice it, like, the diameter is equaling 180. The more times you practice that, the more you just start seeing it in the picture. So just take practice. So not copying answer keys. All right. Let's do another kind of easy one. Parallel lines. We've seen parallel lines in our life before, right? Parallel lines? Remember, like transversals and alternate interior angles? This one's way easier than that. Parallel lines cut your circle exactly the same. What I'm kind of thinking about is if I took this picture and erased all of this stuff, just using intuition, what do you think A would equal? It would be 78 degrees. If you have parallel lines, the opposite segments arcs being cut are congruent. So that's why it says arcs formed by parallel lines are congruent. So if I needed to find A, I would just say, it's the same thing as that other side. We could put little tick marks on there and say A equals 78 degrees. Be careful with these, because sometimes I'll throw a parallelogram in there. I draw a parallelogram. Guess what's special about a parallelogram? You got parallel lines, which means you have congruent arcs. So look out for those words. Let's do an example of this. I was pretty sure I had one. Did I not have one on here? Am I lying to you? Am I skipping one? I think I'm skipping. I don't think I put it on there.
There's number 2 on the homework.
Number 2 on the homework. But I'm not going to do that. Yes?
Are the arcs still congruent?
Yeah, that's what I just said. Yeah.
How can you tell the arcs are congruent when there's no lines, like the sides?
Well, there has to be those lines. That's how you make the parallel lines. You can't have parallel lines without lines.
But like, what if they're not on the line, but on the arc? That just means only the arcs are congruent. There's no parallel lines.
I'm not sure what you're saying. What I'm saying is, if you ever have parallel lines that are on the circle, they cut the arcs congruent. Any other lines don't follow that same rule.
What if it's like just the dashes, but on the sides of the circle, like on the actual circle?
On the actual circle.
Yeah, those. That's what I'm thinking.
Can you draw on here what you mean?
You already did, but
I drew it on there?
yeah, like the sides, like this part and that part, like the sides.
I think you're talking about congruent.
Oh, are you saying that the arcs are congruent? So we could put the marks on here and here as well.
Yeah.
No, we can't. We can't do that. It's only where the arrows go. Because, and if I'm getting your question correctly, picture this. Picture I have this, and I draw a parallel line here and a parallel line here. And if this is 30 degrees, that would make this 30 degrees. Does that top and bottom look like they're congruent? No, so we can't put ticks on those. I get what you mean now. I got you. The little lines, the tick marks. I thought you meant drawing lines on the circle. I was a little confused, but now I got you. So we can only put tick marks. Basically, the arrows point to where they're congruent. So it would just be here and here. That's a great question. That is a great question. We can't put it on the top and bottom. Unless maybe we had more information. If we had more information, maybe we could, but we can't. Does that make sense? Cool. All right, let's get to the quadrilateral one because I think this one is pretty easy and it gets back to a question from our homework. And I'm going to actually go back to that question. When you solve this one, you should have came up with what x equals 110 and y equals 100, right? Real quick, 110 plus 70 equals 100 plus 80 equals,
180.
what does it mean if they equal 180? They're supplementary. Doesn't mean it's a straight line. A straight line is 180 degrees, but just remember these are two angles across from each other. I guess if you add them, they would be. Okay, so if we knew this rule, this problem would have been really, really easy. If you have a quadrilateral inside of a circle, then the opposite angles are supplementary. So now we just got to decide, do we have a quadrilateral and do we have opposite angles? Quadrilateral, what's the definition of a quadrilateral? Four sides. Do I have a four-sided shape in both of these? Okay, so I have 60 degrees. Is G opposite the 60 degrees? So that means G plus 60 equals 180. So what does G have to be? It has to be 120 degrees. So G equals 120 degrees. Let's be careful because these can throw people off. Are L and K opposite, or is it L and J being opposite? L and J. We always got to skip one to be an opposite. We always have to skip one to be opposite. So if I look at this L, this one goes to J. This 45 goes to this K. So J is going to be, what, 180 minus 92? I think that's 164 million.
Yes.
I got it. Let's go with maybe 88 instead. Does 88 sound better than my first guess? Okay. You like my first guess better? Okay. Now I have 45 degrees. 45 degrees is kind of like 180 minus 40, which would be 140, but subtract 5 more and I get 135. Is it a hard rule? You think so? It just takes practice. Practice and memorization. Opposite angles equal 180. So let's go ahead and practice it real quick. So I have a four-sided shape right there, correct? Actually, let's do the simple one first. I got a four-sided shape right here. Think about it. Don't shout anything out. You know you have to write an equation because I have 9x minus 5. Think about what equation you're going to write and write it down. Write it down. We're looking at number 2. Equation, write it down. Write it down. Can you, what time do you have to leave? It's 3 o'clock. Okay. Yep. Okay.
Can I see your question?
Who thinks they know the equation that I need to write? Zavar.
9x minus 5 plus 68 equals 180.
I would go with that as perfect. Hey, quick question. Did anyone do something different? And here's what I was thinking of. Did anyone do 180 minus 68 to actually find out what this angle equals? Do you think that's going to work? Yeah. All right. I'm going to go with this way because this is what I'm doing in both classes. So I'm going to do it one way. If you have another way, just make sure your way gets the same answer. Do whatever way makes sense to you. What are you going to do in the future? Okay, so I'm going to stick with this one. So we'll have 9x plus 63 equals 180. We are going to subtract 63 from both sides. So we'll have 9x equals, 117. 9 definitely goes into 117, and it's going to go in 13 times. We good with that? Okay.
Shouldn't it be 60?
If you plug in the directly guided 9x minus 5 to get
Just 1 second. I have 2 people asking me questions. Let's go here.
I'm plugging in 13 at 9x minus 5 to get h.
If I was asked to get angle G, I would plug it in here and it'd get me G. I have no way to get H or F because I don't have those. All right, I heard 68 somewhere.
Shouldn't it be 68 instead of 63?
I did have a 68, But remember, we took the 9x minus 5 portion, added the 68, so the negative 5 and the 68 came. Does that make sense?
Yeah.
Okay, so I did have a 68 at one point back in the day. All right, guys, let's look at number 5. Number 5, I need an equation. Joseph, you got it? What'd you come up with?
5x plus 1 plus 3x, 13x minus 77 equals 180.
Why'd you write it like that?
Because they're opposite angles.
Because they're opposite angles of a quadrilateral, right? So we have W is our 5x plus 1. Our Y is our 13x minus 37. Did anyone solve this yet?
How does only those two?
Just 1 second. Did anyone solve it yet? What'd you get?
197.
197. Did anyone else get 197? Ooh, maybe we should go through this. I don't disagree with you. Let's go through it. All right, let's go back to Owen's question because we're going to actually go through this.
I understood now. It's because they're opposite angles.
Those are opposite angles. All right, let's go through this one. All right. You got x equals something. Be careful because it's not asking you for x, it's looking for a measure of angle y. Yeah. Sure, what'd you get? You got 119. You got 187. All right. I got 67. Let's go through this because we have like 5 different answers floating out there. So let's go through it. All right. So we should have 18x minus 36 equals 180. We'll add 36 to both sides. So we'll have 18x equals, what is that, 216? How many times is 18 going to 216? I think it's like 12? 12 times? X equals 12. I hear some people found a mistake. Now 12 is not our answer. Ty, do you mind turning around?
No, this was a mistake. We made the same mistake.
Oh, okay. All right, so we have 12, but that's not our answer. We do have to find measure of angle y. Measure of angle y equals 13 times x, which is 12, minus 37. What does that come out to? Are we all on board with 119 degrees?
No, because you have to get 180, right? Oh, no, that's
Nope.
you're finding W.
If I was finding W, yeah. Are we good with 119?
Yep.
Grant doesn't look, okay, you are? Okay. You just looked a little angry at it. You're just like, you got the angry eyes at it, like it's broken, not me. All right, guys. Now's the time to buckle in. Buckle in, we get to the 2 hard ones. You're just going to have to bear with me and just go with this. These are true. We're not going to sit here and prove they're true. That will take too much time. So we just have to accept they're true. The perpendicular bisector of a chord is a diameter or radius of the circle. Let's go through this both ways that it's important. One way is not as important. I'll be like, screw it, let's go to the next one. So we'll go to the unimportant way first. So, to be a perpendicular bisector, I need to have a right angle and I need to go through the midpoint creating these 2 things. If you see this, that makes this line automatically a diameter. So if you see a right angle and these both being congruent, you automatically have a diameter. We will not go that direction. We will not be going that direction. We're going to go the other direction. How can you tell from a drawing that something's a diameter? It goes through that middle point, right? The center of our circle. It touches both sides. So would you agree, even if I didn't have this word, that this would be a diameter?
Yes.
If you see a diameter and it has a 90-degree symbol here, you will immediately put tick marks on it. You will immediately put tick marks on it because it has to be congruent because that is a diameter and it's perpendicular, which means it's a perpendicular bisector. Can we keep that in mind? Okay, let's look at one of our problems. Let's look at number 6 and 7. Number 6 and 7, and I want us to kind of forget about part of the drawing for a second. Now, I said if you see a diameter at a 90-degree angle, right? Do you think this would suffice? Yes, because it's half a diameter. So this is technically, if I finish this, this would be a diameter, right? So it follows the same rule. Do we see something that goes to the center in a 90-degree angle? What did I say we should add as soon as we see that? Tick marks. So let's add tick marks to it. Whoop, whoop. And let's bring the rest of the drawing back in. Those tick marks are important because I need to find the length of VW. I need this entire length. Part of this we already could have done. Yeah. What was that?
24.
Yeah, you ruined the whole surprise of the answer. He is correct. It is 24. How'd you do that? Can we backwards design it and then we'll go forwards? Backwards design it for me. So you had 24, which means you must have had 12 at one point.
15 squared minus 5 squared. And then I got 12, and then I multiplied that by 2.
Okay, so reverse engineering it. Joseph realized that this is a right triangle. A right triangle, we can use a squared plus b squared equals c squared. So I'm going to find, I'm going to call this x. I'm going to find this, which means I'm going to have 5 squared plus x squared equals 13 squared. Joseph went one step further and he said, well, why would I plug all that in when I can plug in x squared equals 13 squared minus 5 squared? So Joseph just moved it to the other side. I don't care how you solve it. Take a second, solve this equation. Joseph already gave you your answer.
24.
That is not the answer I want now. I want the x value.
Okay. W.
X should equal 12. Yeah.
I was doing.
Yeah, you have it.
Yeah.
We should probably do the work. I don't know if you did in your calculator.
Yeah, I did.
Okay, yeah, I see it in there. All right. So are we okay with x equaling 12? So if this equals 12, this equals 12, and just like Joseph started with, he said VW equals 24. Cool beans. Go, Santiago.
Would angle VCY also be a 90 degree?
VCY, yes. This would be a 90 degree. This would be a 90 degree. In fact, all 4 of them are 90 degrees.
And you know it's 90 degrees also just because of vertical angles, right?
And vertical angles as well. Yeah, good job. Yep, but we know all 4 of them because of straight line and vertical angles gets you to the other side. Okay. Next thing. We need to find arc YW. So let's highlight arc YW. Can someone pick a letter that's not up there already?
H.
Oh,
I think I heard your F. We'll call this F. We'll do H next if we need to. All right, guys, like I said, we need to focus here. I need to find F. How does F relate to the shape that I know the values of?
oh, if you know the internal x, then it's just
Our central angle X here, right? These should be the exact same. So if I mark this F, what should I mark my central angle? F, the exact same. So would you guys agree that if I found this, I would have this? Okay, and this is part of a right triangle, right? I'm going to go over here and I'm going to draw that right triangle. Just to get the old juices flowing.
we have 90.
So we have a right triangle, we have 90. Ooh, that's a bit aggressive. All right, so we know that I'm looking for this is my F. I'm just going to use the values that they gave me, the 5 and 13, because my number could be wrong. How do I find a missing angle from a right triangle?
Pythagorean theorem.
Not the Pythagorean theorem. That doesn't get us angles. Inverse. It might be sine inverse. It is a trigonometry. We need trig.
Log.
We need trig. We need sine, cosine, or tangent inverse. You're telling me it's... I heard cosine. Can someone describe to me how you knew it was cosine? Because it's what? Because it's next to the 90? Oh, I got you. So we have an adjacent to the angle, and we have the hypotenuse. And remember, it's so, ka, toa, ka, adjacent, hypotenuse. This is definitely adjacent because it's next to the angle I'm looking for. So we are going to use, I don't care how good you are right now, I'm going to go through the whole process. I'm going to say I know I need cosine. I need cosine of angle F equals adjacent over hypotenuse. Someone already said it, but how do I get the cosine to the other side? Reverse it. Inverse. Inverse is the word I'm looking for. Flip it and reverse it. All right. So we'll have cosine inverse of 5 over 13. We should know we need our calculator for this. And we know it's going to be an approximate. I need it to the nearest tenth. I need it to the nearest. Say that one more time. 67.4. Can someone confirm it's 67.4 degrees?
Yes.
Okay. Now remember, you guys agreed that if I got F, that meant I got YW as well. So this is actually our answer. Doing okay? We doing okay? Yeah.
So would it only show up as cosine? It could also be used sine.
We could have used sine because we did know X was 12. So we could have used sine of opposite, which would be 12 over 13. You would have had to use a different side to use sine. So remember, depending on what side you're using, you have to use either sine, cosine, or tangent. Okay? And we'll do another example in a second here. All right. We got one more rule we have to learn, but let's try the problem without the rule first. All right, we are number 8 and 9. Notice I kind of changed the numbers to 8 and 9 to reflect. I think you were saying the 16 and stuff too. That's wrong. All right. Let's stop for a second. Let's think about this. I'm going to turn this into a problem you just saw. So I'm going to erase some stuff here. We're going back in time. We're making a shape. I have a radius and a 90-degree angle. I have a radius and a 90-degree angle. What's my next step? They're congruent. I have those equal parts. Both good ways to say this. I'm going to use double tick marks because we already had tick marks. All right. Now, I have double tick marks. Now, let's look at the other side. Do I have another radius and 90-degree angle? Okay, so I know that this segment is congruent to that segment, right? So I could put a triple tick mark. Because the only rule I have is 90 degrees means that both those things are congruent. What does intuition... Yeah, do you have a question or an answer?
Question.
Yeah.
Would GM and NJ be
GM and NJ? Yes. Because those are both radii. They will always be, no matter how we mark them, so if part of it is. But I want to get back to, do you see my diagram? Let's just look at it. Let's use some intuition, and then we'll see if there's a rule for that. Look at my drawing. I have double tick marks and triple tick marks. What does intuition tell you? I have a terrible way of leading you to an answer, but does someone see something we could change on this? Just intuitively, yeah.
They could all be the same.
They kind of look like they'd all be the same, doesn't it? Like NK would equal to HN would equal to these. Like we could maybe put 2 tick marks on it. Yeah? Shh.
LH and KH are the same thing.
LH and KH?
Yeah.
LH and KH? Yeah, those are probably the same. Yeah, they have to. It kind of looks that way, right? But that depended on Joseph being right. Because Joseph said, maybe all 4 of these are congruent. If all 4 of them are congruent, then your intuition is correct as well that those are, because we'd have 2 congruent chords, we would have those. So, what I want us to look at is the last thing that we need to learn. If you ever see the 2 chords are the same distance from each other, and the way you're going to see that is you will have tick marks between these. If these 2 are the exact same size, only if they're exactly the same size, can I say all of these are congruent as well. Xavier, did you get that? Because that was really, really important. Can you kind of read back what I was kind of saying? Do you want me to say it one more time? Okay. So I said, if these distances are the same to the chords, that means all 4 of these are congruent. If these aren't congruent, so let's look at this. If I get rid of those, then I have to go back to doing something like this. Are we clear on that? No tick marks mean all 4 of them. I mean, we still have these 2 congruent, but as soon as I bring these in, I can change them all to being the same. Amber alert. I shouldn't be active, but my phone is still doing the timer. Okay, all right, let's get this done. All right, let's go back to that problem. And this is the last one we're going to do, because we're going to skip the last one. Because I understand, these can be a little bit difficult and people get distracted. Let's finish this. I have 2 tick mark, 2 tick mark, 3 tick mark, 3 tick mark. What do these 2 tick marks let me do? What do those inner tick marks let me do? Yes? They are the same, and so I can turn all of these into double tick marks. That's important to this problem that all of those are the same. All right, so our job is to find pH. We have more information. We have HK equals 30. So if HK equals 30, instead of writing 30, what am I going to write instead? I'm going to write 15, 15, 15, and 15. I'm going to go, this is 15, this is 15, this is 15, this is 15. Bam! And I also have PM is 8. PM is 8, which means that this is also 8. I need to find pH. What kind of triangle is the one with the 8 and the 15 on it? It's a right triangle. How do I find a missing side of a right triangle? Pythagorean theorem. So we're going to go ahead and we'll call this H. Oh, we already have an H. Can you pick another letter, Will?
A.
A. So we'll call this length A. So I'm going to go to find pH. I'm going to go 8 squared plus 15 squared equals my A squared. A equals what? 17. 103? 44? 17.
Oh, I was doing. Well, yeah. No, A equals 289. Then the square root of 17.
What does A equal? 17, right?
17.
17 is correct. A squared would equal the other one. So we have A equals 17. Okay, we're supposed to find the arc JG. Now pay attention to what I'm about to do. JG is this entire arc here. I'm going to go ahead and find half of it, because half it leads to, just like Will said, a central angle right here. Can someone give me a letter that's not A or on the drawing? M. Is M already on there? Oh boy, I heard Z though. Our backup will be Z. Okay, I'm going to find this, which will get me that. Try to stay ahead of me. Try not to just wait for me to write it and distract each other. So I have a right triangle. I have a right triangle. I'm going to try to draw it the same way. I didn't really do a good job. But we basically have this, this, and this. That will be my H, N, P. I'm trying to find this Z. I do have an 8 and a 15 and a right angle. I'm going to give you 6 choices, so don't just shout out. Just listen to my choices. I need to find z. Am I going to use sine, cosine, tangent, sine inverse, cosine inverse, or tangent inverse to find it? All right, who thinks it's sine? Who thinks it's cosine? Who thinks it's tangent? Who thinks it's sine inverse? Who thinks it's cosine inverse? Who thinks it's tangent inverse? It's actually going to be tangent inverse. I agree with tangent. Tangent will get us there. But we're going to end up using tan inverse because this is opposite and adjacent. We aren't using the hypotenuse. So we would do something like tangent of z equals opposite over adjacent. And so we'll have z equals the tan inverse of 15 over 8. Z is going to be about what? I don't think that's just z. Is it just z?
Yeah.
Z equals 61.9 degrees. Is our answer 61.9 degrees? Oliver, you said no. What do I have to do to 61.9 to get my full answer? Oliver, I don't know.
You have to round it.
Well, not round it. Not round it. Can someone help Oliver out? Ben? I need to double it. So remember, RZ is here. I need that entire thing. So we need to double it. So to get the measure of GJ, we would double it. We'd have 2 times 61.9. So what is our measure? 123.8 degrees. I'm going to skip the last one because we're running short of time. We got 5 minutes left. I'd like